morning, everyone, or good afternoon, and welcome to this month's monthly Kube Chat. Today, we'll be talking all about tagging essentials in Kubernetes. And digging right in here, if my slides will work, here's our agenda for the day. So we'll cover some, brief introductions about KubeCost, as well as our speakers. Then we'll go into, what the heck is tagging and labeling? Why should I be doing it? And then we'll show you some best practices for how to get started, as well as enforcing auditing and compliance. Then we'll show a quick demo of KubeCost and how you can manage labels through KubeCost and to better manage your costs. And then we'll save some time at the end for a Q&A. And just to give you an update, we will be recording this webinar today. So if you can't stay for the whole thing or want to share it for others, do not fret, because we will be sharing it out with you along with a link to the deck. And we did get a number of pre-submitted questions, so we'll start with those at the end. But if you have any questions throughout, feel free to just drop them into the Q&A feature of your Zoom there, and we'll cover those as well. And then one last thing I wanted to flag is both myself and Joe and Sean are all operating from new computers. And so we just realized this morning we're having a couple issues with Zoom. So if anything happens throughout and one of us loses access or something is wonky, just bear with us, and we're really sorry. We're kind of realizing we have issues as we go, so we'll do our best to make sure that things keep running smoothly here. All right, so first off, in case you're unfamiliar with KubeCost, just wanted to give you a little background about us. So we started back in early 2019 as an open source tool. We're designed to give developers clear visibility into their Kubernetes spend. And today we're empowering thousands of teams, from startups to enterprises, to better monitor their cloud costs, reduce waste, and just strike that right balance between cost, performance, and reliability. We're able to run, wherever you're at. So regardless of cloud provider, or if you're, air gapped or on-prem, we can help you out. We just really work to provide that single pane of glass for your costs to help you make better informed business decisions. And today we're managing over $3 billion in spend with some really amazing customers like Coinbase, GitLab, Johnson & Johnson. So we're really excited to work with you if you also want to work with us. And now moving on to our first speaker today. So this is Joe. Joe is our principal product marketing manager here at KubeCost, and he has a ton of experience in industries, including cybersecurity, cloud, fintech, you name it. I did drop a link to his LinkedIn there, so if you want to connect and ask him questions, feel free to reach out. I promise he won't bite. He's probably the friendliest product marketing manager I've ever worked with. And then our second speaker today is Sean. So Sean is a solutions engineer here at KubeCost, and interesting enough, he actually was on the FinOps Foundation committee for being the working group to create the best practices for Kubernetes labeling. So he is like literally your resident expert here for the topic at hand today. So you're going to be in good hands. And I also dropped a link to his LinkedIn. So if you want to connect and talk about labels or Kubernetes or what have you, feel free to reach out. And with that, I will go ahead and pass it off over to our speakers.
Thanks, Dee. Tagging. It's like one of the simplest things in Kubernetes as a concept, as an action, as as a resource. I mean, essentially, it's just attaching it is metadata that gets attached to things, right? Containers, workloads, resources of all kinds. It is kind of like I guess developer notes, right? And markup that you might find in code that helps you understand, like, what the heck is this, and why is it here? And tagging, even though it's so simple, is hard to do correctly over a long period of time, right? Consistently. And it matters a lot. Like, it can become the difference between either having really good visibility and understanding of who owns what something is, whether it's necessary, where it belongs, or really flying blind and dealing with chaos and a hot mess. And it makes it almost impossible to track and do things like allocating costs if you don't tag them for categorical purposes, right? Um, and it's visibility into more than just costs. You get to see things like who owns this resource, who has the authority to make changes to this resource. And it helps you identify things that are wasteful, right? Maybe you find resources that have been labeled or tagged with a product that's been deprecated and no longer exists, and yet that resource is still alive, floating out there in the ether, generating cost that ultimately contributes to a cloud bill that's probably going to be higher than you anticipate. Um, it also, when done right, simplifies things like accurate FinOps reporting, uh, makes it easy to do show back and charge back and allocate costs to teams or products or business units or whatever it is that makes sense to you. It works much better than like licking your finger and sticking it up into the wind when it comes to understanding data-driven insights, doing things like planning and forecasting and preparing for the building and launch of maybe another application, as an example. It's also used to drive policy and procedural enforcement. So tags are useful across the gambit. They're more than just attaching a nice piece of information to a Kubernetes resource. The application and use cases for good tagging are deep and broad. Next, please. So, what is tagging in Kubernetes? Oh, actually, this one's over to you,
Yeah,
Sean.
that's me, Joe.
Sorry,
It's all good.
I'm stealing your thunder.
I'm sure it'll happen quite a few times. So tagging Kubernetes, right? If you're familiar with cloud-based environments, then this is no different than what you're already familiar with. The biggest difference may be that the nomenclature, right? So typically cloud providers use the concept of tags, whereas Kubernetes, we're going to use the name labels and annotations. No matter what you call it, at the end of the day, it's a key value pair. Now, obviously, there are some minor differences between the two that you should definitely look into, typically around like syntax and what characters are allowed to be in both the key and the value. So definitely take a look at that. Regardless, Kubernetes uses labels and annotations for a few different reasons. Even beyond cost allocation, you use things like label selectors to determine where your Kubernetes workloads are going to run, especially when you're talking about like different size node types or the inclusion of GPU resources. Whereas annotations are used more like additional metadata, right? So not typically not used for selectors and identifying where resources run, but are useful for additional tools like automation or some of the topics that we're talking about today, which is like allocation of cost based on those different concepts. When it comes to tagging resources in Kubernetes, as Joe was touching on previously, you can do it in a few different places. Typically, you'll want to do it either at the namespace level. A lot of customers use namespace as a form of tenancy within Kubernetes, like a logical grouping of resources. So basically, all the resources running in a namespace also inherit those same labels and annotations, or specifically at the pod level, right? So even if you're adding labels and annotations to, like, say, your deployments specs, you want to ensure that those are actually on the pod specs as well, so they roll down to the actual workloads that are consuming resources. And then, of course, the additional resources being consumed by those workloads, right? So any storage, whether it be a persistent volume or like a CRD pointing to a different type of resource, you want to ensure basically anything that has a cost associated with it, at least from this perspective, also includes those same labels and annotations. Kubernetes, not unlike cloud, also is going to have a number of like canned out of the box labels, especially for deploying Kubernetes in a cloud-based environment like AWS, Azure, GCP. A good example would be like the instance type, right? You'll see a label for that, or the region or the zone that a particular node is running in. Those are node level labels. And something like the node group, or as we talked about selectors before, like if a GPU is attached to a node. Next slide, Nate.
So lots of opportunities to get tagging wrong, right? It's actually much easier to do a poor job of tagging than it is to do a really good job of tagging. So what are some of the implications of poor tagging? Well, first, you might have to move in with your ante and on the bell error. Second, you're going to run into visibility issues. Absolutely. And for a lot of teams, you don't kind of know how good you got it in an environment where good tagging is being applied. Process and procedure has been wrapped around tagging processes. until you join a company or a team that's really good at it and you realize, just how good you had it before. First and foremost, you're going to get an incomplete picture of things. You're going to get just enough visibility if you're doing a poor job of tagging, not no tagging whatsoever, but some tagging, and not necessarily, adhering to best practices or being consistent in the application of that metadata. You're going to see some, but not all data, and that might drive you even crazier than if you're unable to see anything. You're also going to run into issues around accountability and standardization. You're going to constantly be telling teams and asking developers to change the way that they're tagging resources, start adding tags to resources, or to quit tagging it in ways that maybe don't fall in line with the rest of the organization or the rest of the team's process and procedure. You're also going to have no ability to assign costs to teams or to individual developers, whether they're owners of resources or not. You're not going to be able to understand future spending trends and then allocate budget accordingly, or let your boss know that, hey, this is going to be a more expensive month, and it's because of these like sensible and easy to understand reasons. You're also going to run into a lot of waste and inefficiency. You're going to have less time to write code because you're going to be cleaning up your mess, other people's messes. And I haven't met a developer that would love to spend more time retroactively fixing tags and labels than they would prefer to be, building great code and applications. You're also going to get headaches and pains from things like regulatory and compliance, security pressure. You're going to have a compliance enforcement department or an individual banging your door, constantly asking, who owns this resource? What is this resource for? Can you help me understand what product, what project these resources are aligned with? And you're also going to find that it's going to be much harder and more expensive to scale, right? When I keep having to insert human beings into processes that could be or should be automated, number one, it's going to slow down your velocity in your CI/CD pipeline. It's going to take longer to get fixes and features in the customer's hands. It's cost more to do the development work that you're doing. And you're certainly going to run into some human error issues as well, where mistake. You can go to the next one. Okay. So some common pitfalls and some challenges that you might run into. Um, it is not about just tagging everything, right? Yeah, that is absolutely an aspect of it. Be consistent, tag everything that needs to be tagged, figure out, consistent ways to do it. But it only really works when you've got a structured and kind of a methodical approach that everybody gets on board with and then executes in relatively the same way. You're going to run into incomplete or inconsistent data. And again, that's going to be just as bad, if not worse than having none at all. Um, when you try to set up tagging standards, but you don't enforce them, you're going to get the same end result as not having standards at all. Um, and untagged or incorrectly tagged resources are going to turn into these ghosts that kind of haunt you everywhere you go, far into the future. Um, and it's going to make it really challenging to become efficient and accountable in your practice. Um, and look, you don't want tagging gone wide. If you've got way too much metadata, where you've got like redundancy, where you've got the same metadata over and over and over again in every place, it's going to make teams feel like they're drowning in data instead of being empowered by data. It's not going to benefit them in any way. They're just going to end up, struggling. Tagging issues in terms of like quality and the challenges can also lead to scalability issues, right? It's going to be, you're going to get growing pains, and that lack of alignment between teams is going to rear its ugly head. It's both inside and outside of the engineering department, right? So tagging doesn't affect just your app dev team. It affects relationships between app dev teams, relationships with platform teams, with DevOps and operations, with finance, let's get on. So there's a lot of pitfalls and challenges here that you can avoid by implementing and then executing and standardizing on a good set of best. You can go to the next one.
Sure thing. All right. So key principles for a scalable strategy. We've talked about it a little bit in the prior slides, but basically standardization, right? You can't just say everyone go tag your resources. There needs to be a direct actionable request on how resources should be tagged. So there's a lot of value in building a standard that applies across all environments that tagging is available, right? So whether it be cloud, through your cloud providers, on-prem, through a virtualization platform, of course, Kubernetes, a lot of SaaS providers are also extending tagging capabilities that also show up in the bill. So basically find an approach that works across all of your providers so you can have a standard and consistent tagging and labeling structure. The important caveat here is that everybody does tagging and labeling a little bit different when it comes to like what you can use in the key property as well as the value property. Most providers are case sensitive. So if you have, say, a tag key called cost center, maybe one person puts it in as all lowercase, another puts it in as all uppercase, someone else puts it in as camel case. Those are technically three different tags or labels, even though they have basically the same key, because most providers treat a case separately. Alignment on tags with business needs, right? You can't just ask an engineer to define what tags are important. You basically need to ask everyone that's going to be consuming the data, right? Because what finance wants to see is going to be different from what engineering wants to see. It's going to be different from what product wants to see. So it's very important to include all those different groups and teams in that conversation to ensure that all the different possible use cases are covered. And you'll typically see not just things like cost center, but there's going to be business data, right? Like who owns a resource or what team is responsible for supporting that resource. Automation, right? I mean, when we talk about the DevOps world that we're in right now, automation is king. You want to ensure that the approach and the standard that you do adopt can be automated. So that can be from a proactive perspective where you're not deploying resources unless they meet that standard. Or it can also be from reactive perspective, right? Even when you adopt a tagging standard, the odds are that a lot of your existing resources are probably not going to have those tags in place. So you'll need to have an approach to go ahead and retroactively adjust those resources to adopt that new tagging standard that you have. The automation can come in the forms of like a CI/CD, right? Whether it be Ansible, Argo, or Flux, they can help you on that journey. Of course, if you're taking like a DevOps approach for deploying your infrastructure as well as your applications through something like Terraform, that can help you apply those tags. And then, of course, a policy engine, right? Something that like an OPA or admission control that will prevent resources from being deployed. Auditing, right? The standards and the work stream only makes sense if you're actually auditing it over time. There's always going to be drift. There's always going to be exceptions. So you want to make sure that you have a good handle on what the environment looks like from your tagging perspective. Sprawl, right? It is possible to have too many tags, right? You're basically introducing a lot more data to your pipelines. So you want to make sure that the tags that you are adopting are concise and align with those business needs we talked about earlier. You can't just let everybody add a tag for whatever they want. Otherwise, you're going to get a lot of sprawl with your tagging approach. And shared responsibility, right? In a sales organization, everyone is a salesperson. In a support organization, everyone is a customer support representative. Same goes with tagging, right? Everybody is responsible. See something, say something kind of situation, and ensure that your resources are compliant to the standard, and encourage your teammates to do the same. Next slide, Dee. So talking a little bit more on conventions and standardizations. Syntax is key. Again, I know I'm kind of a broken record here, but it's really important to capture what the business needs. Kubernetes takes a little bit of a different approach for labels. You'll often see a lot of labels, especially ones that are applied by like a cloud solution, service provider or other automation platforms. Will typically include like a domain name. So it almost looks like the URL of like a website you're visiting. Some examples on the slide here, like you'll see like app.kubernetes.io, right? So name, instance, component, part of that domain name is basically saying the responsibility or who owns that resource. It's also referred to as a prefix. It's optional, right? So for your own labels and tags, you don't necessarily need to adopt that, but there may be value in doing so. So make sure you fully understand the purpose of that prefix. Not unlike like cost saving measures in like a cloud world, we find that the directives are that succeed or are adopted typically come from the top of the organization. So you definitely need buy-in from the C-suite to help your tagging approach and the adoption of that approach. And also for accountability in Kubernetes, you really want to make sure that the actual workloads consuming resources include those labels, especially from like a Kubernetes perspective. The resources that are consuming the resources are the ones that cost something, right? Yeah, yes, you can add labels and annotations to like your config maps, and that may be valuable for your business needs, but from a cost perspective, right, those resources don't typically cost money, so there's not a lot of value from allocating the cost of those resources. Next slide, D. Which brings us directly to cost allocation and team ownership, right? The main reason we're here is to help you on your tagging journey from a cost perspective. So you want to ensure you have the necessary labels in place for actionable data. A lot of the teams we work with are going to want like an all-encompassing tag that covers, say, a team or a department, whereas the engineering side is typically going to want labels that separate by like a component or a specific application, because that's typically how they work. It may not be as simple as mapping an application directly to like a dedicated cost center. As an example, a lot of organizations, a cost center may include multiple applications or multiple teams. So it's definitely important to ensure that there's enough metadata to support the various use cases you may have for slicing and dicing that data, because you want to be able to break down those costs based on the persona that's looking at the information. Which means the more granular you can get, typically the better. Allows you to be way more focused on things like budgeting. So instead of setting like a budget for your Kubernetes workloads at like the team level, you can set it at like the application or the component level, so you can understand the true cost of each individual component within your environment, or the roll-up cost based on like the full team or like department perspective. Not unlike cloud, one of the key areas of waste in Kubernetes is orphan resources, whether that be physical volume that's no longer being consumed by a pod, or even a full-on application that perhaps has been deprecated or sunsetted, or is misconfigured, right? From a Kubernetes perspective, if a workload is not consuming network capacity, it may not be doing anything of value. So having a way to basically allocate the cost of those orphaned resources, so now you can make it a bit more actionable for the relevant owners to remediate those orphan resources. Next slide, D.
Awesome. Great. So, this all sounds like a lot of work, right? If you've been like paying attention, you might be feeling doomed to like manually tagging everything for the rest of your life. But there's good news. It doesn't all have to be done bespoke by hand and knitted like a quilt. Actually, automating much of this really helps with things like consistency and accuracy. And it's going to go a really long way to solving security and compliance challenges because again, you're removing kind of the human oopsie factor from a lot of these activities. You can lean on IAC tools like Terraform, Terragrunt, or Helm to automate a lot of this tagging work. You can set up GitOps workflows that can do this for you and identify when things aren't there and prevent them from progressing in your CI/CD pipeline. Admission controllers, policy as code tools, they can do things like preventing merges or deployments from happening if labels or tags are missing. And let me tell you, being responsible for a failed deployment because you didn't tag your thing is a great way of remembering to tag your stuff in the future. You will be the popular person that failed launch day. So don't turn your back on automation, right? Like you might cross your fingers, hope everything that goes right, and like get back to building applications, but you're going to need to perform regular audits. And hey, have the bots keep an eye on the bots, right? Use automation for compliance checks and to find missing or incorrect tags to watch the watchers, right? And of course, use really killer tools like Kubectl to simplify and then reinforce good practices like these, and then share the outputs with other teams across the organization, help them get better at their process and procedural, P's and Q's as well. Next slide, please. So how do you ensure like this consistency? We keep talking about how consistency and standardization is so important. Number one, define a policy. Make sure that it is understood company-wide, that new developers coming into your environment that are, going to be hands-on keyboard have been trained properly on your process and your procedure. Make sure that they understand what is required of them and when, and then give them fast, positive feedback for doing it correctly. And, make it, I guess, an accountability culture within your organization where everybody reinforces each other's proper use of tagging, whether that's at a team level, cost center level, or down to the environment. Standardize. Make sure, as Sean mentioned, that you're using proper capitalization, that you're consistent across the ways that you do it. If you're doing things with special characters, make sure that that is something that is, being implemented across the board. Again, inconsistent application of tagging can be just as challenging as missing tags altogether. Use things like the same key value pairs across dev, staging, production, whether that's on-prem in AWS or Azure. That consistency across all environments and practices will pay off in spades for you. Do enforce, right? Enforce via daily stand-ups with your team, enforce via automation, enforce via policy as code, as many places as you can to catch those and kind of shift good behavior left in your organization is going to only help you get better and better at it and catch mistakes long before they turn into things like a failed deployment. And then provide visibility. Make sure that everybody can see and then everybody understands when things go right and when things go wrong. Use dashboards, use reporting, use Slack, set up automated Slack messaging to teams and users when the system finds that there's things like missing tags. There's a lot of great webhooks you can tap into to do that kind of positive alerting. And next. Lastly, unless you were born in the cloud and came out of the womb with great tagging, habits and hygiene, you're probably going to deal with having to clean up stuff that existed before you started to get good at tagging and implement standards, process, and procedure. So this is where you're going to find a lot of those orphaned resources. This is where you're going to find a lot of those misplaced resources that are still out there costing you money that you don't necessarily need to be spending on. So use KubeCost, solutions like KubeCost to identify resources that have been orphaned, idle costs, things that people just forgot about, like a load balancer after you tear a cluster down. Run custom scripts that will flag and find resources that either have tagging that misaligns with your standards or that are incorrect or missing altogether. You can automate some of this remediation by using admission controllers and Terraform CI/CD workflows. You can absolutely retroactively tag resources. If you've got existing workloads, you can do bulk updates, right, to make it a lot easier and faster to get things back on track. If you use a solution like our new family at Cloudability, they can do things like virtualized tagging, where if it's just too big of a deal and it takes moving of mountains to be able to do that, there are ways to still solve for those challenges. And look, it's like when do you plant a tree? The best time is 20 years ago, and the second best time is today. The way that you prevent future errors from becoming a big problem is by implementing these kinds of changes now, requiring tags now, putting them into your deployment templates, enforcing them at the time of provisioning, educating teams on best practices, and putting a stake in the ground that says we're going to do it different and better moving forward, and then applying those accountability and positive, feedback reinforcement practices to keep that going. Go ahead and go to the next.
All right, auditing for accuracy and compliance, right? Kind of digging in a bit more to what Joe was talking about for identifying missing and inconsistent tags, right? This effort is not just to help you identify waste and cost, but to help you identify those resources that are not tagged properly. All right, so setting up a dashboard, or more importantly, subscribing to a scheduled report, right? So you don't need to actively go to like a web portal or something to review the current state, maybe get something in your inbox or a Slack channel or a Teams channel on a regular basis to help you understand, how you're tracking towards compliance of your resources. Um, I like to look at the like untagged resources report, right? So if somebody doesn't own something, there's no process in place to add those tags back to those existing running resources. We need to understand who owns them, what they do, or what can be done to remediate them. Automatic remediation can be tricky, right? Because you want to ensure that what you're doing doesn't, number one, impact any production running workloads, right? The last thing you want to do is add a tag which brings down a service or something, because tags can be used for configuration in the Kubernetes world, or labels rather, I should say. So when you do add automation, be sure you're cognizant of that. For remediation, going on top of the standards, ensuring that everything is in place and defined as you would expect it to be. Enforcing the standards, whether it be automatically through your pipelines, your build processes, or your deployment tools, or even manually if you have like a report or just some scripts you can run to kind of pull that metadata out so you have an easier view into kind of how that's tracking and what it looks like. Not unlike if you're familiar with the FinOps Foundation, not unlike the maturity model, the whole crawl, walk, run. There's different steps that kind of be taken here, right? The crawl step being just adding the tags to those resources, making sure the label standards are applying. Whereas a run is going to be fully automated, right? You don't really have to worry about it as much anymore, apart from like a regular cadence, just to make sure like, do we need additional labels? Can we remove some of the labels that we have? So there's a bunch of different ways you can attack that. And then tracking it over time, right? So from a cost perspective, it'd be very easy to graph and chart like, well, here are the tagged or untagged resources back in September of last year versus today. Here are the untagged resources, right? The expectation should be that the cost of those untagged or those out of compliance tags are going down steadily over time. Next slide, D. So building into that automation topic, proactive governance is key, right? If you can either prevent workloads from being deployed without tags or have some automation in place to automatically add the relevant tags, it will be much easier for everyone to operate, as well as for all those resources to be tagged and remain tagged. There's a number of different solutions out there. We've done a few blog posts on them. The ones that stand out are Kubernetes, right? The policy tool, as well as just the standard open policy agent to keep those workloads from being deployed unless they satisfy your tagging requirements. Using CI/CD tools like your Ansible, your Argo, your Flux to ensure that they're all deployed based on your agreed upon standards. That way you don't have to worry about manually updating or modifying your manifest to contain those relevant resources. Building on top of the tagging policies, we find it that if the tagging policies match or standardize across cloud and Kubernetes, it's way easier to build like your total cost of ownership reports and understand the full cost of an environment, not just like specific to one environment or another. So be sure that you're enforcing those standards across those environments as well. So not just adopting the standards, but also enforcing them across cloud as well as Kubernetes. And then, continually ongoing maintenance, right? A report once a month that the different teams get that see kind of how they're tracking towards that compliance, or even adding it as part of like a dashboard. Maybe they've got an observability dashboard that they view on a regular basis where they can see the state of all their different applications and services. Maybe that could include like a tagging map as well to understand kind of like not only the cost of resources, but what resources need additional attention from a tagging perspective. And I say with that, we can finally get to some demos. Let's see if I have properly configured my laptop to share my screen. Let's go ahead and pick that window there. Everyone should now see the kube cost overview minus this little zoom toolbar in the way.
We are
Perfect.
good.
All right, cool. So I'm just going to level set really quick on KubeCost. I'd imagine many of you are probably familiar, but KubeCost is primarily driven for Kubernetes cost allocation. We are deployed as either self-hosted, where everything remains 100% running within your environment and within your control. And we also have a SaaS model for those that prefer to focus on the art of making their beer as opposed to managing their solutions that highlight their cost. Regardless of which deployment model you follow, the look and feel is exactly the same. We're going to start with talking about kind of like the allocation, or more commonly referred to as visibility, right? Kubernetes is a black hole. So understanding your cost from a Kubernetes perspective is hard. Kubectl is meant to help you understand those costs from that Kubernetes layer. We operate throughout the entirety of Kubernetes hierarchy, so all the way up to cluster, all the way down to container, and everywhere in between. You've heard some common concepts that Joe and I have said throughout this call, right? Namespace is a common one, and of course, labels, the whole reason we're here. We can work with any and all of those. We're automatically pulling in the labels, so you have a pre-populated list of what's available. You'll notice some sanitization of labels here. I know there was a question or two about normalization as well prior to this webinar. Kubectl is going to automatically, I wouldn't say normalize, but kind of like demystify some of the stuff. So if there's any spaces, some providers do allow for spaces in the key name. Special characters like slashes, periods, and stuff, we're going to replace those with an underscore, just so you can kind of more easily see everything. But we are going to pull them in, so you can very easily select them from this list. Like if I want to focus on, say, app, right? This is a very standard Kubernetes label you'll see in most environments. I'm now breaking down my costs by that app label that's applied across my environment. You'll see at the very top of the list, unallocated workloads. That essentially indicates workloads running in Kubernetes that don't have an app tag or label on them. So we can explore that, right? We can drill into unallocated workloads. We can very easily see, so now we're looking at the controller level, right? So your deployment, daemon set, replica set, stateful set, so on and so forth. We can very easily see all those different workloads that are missing that app label. And then we can kind of further drill into here as well. And we can find, the actual different pods and stuff that are involved or missing that label. So this will help us identify kind of over time which resources are no longer labeled. I was playing around a little bit earlier today. I was thinking, like, what if I want to just track what's unallocated, right? How that cost is trending over time. So if I go back to aggregating by my app label, right? So see aggregator, cost analyzer, all different applications running here. I can now add a filter on that same label. So go custom label, we'll scroll down and find app on here. And then now we'll put in our value for unallocated. Let me see how my typing and spelling skills are today. So that's going to be double underscore unallocated double underscore. And now you'll see this view has changed to just looking at the workloads that do not have that app label. And we can break this down a little bit further. Maybe we'll go to 60 days. It's a demo environment, so I don't imagine you'll see much change here. But essentially, you can see there's a little bit of downswing here, how basically the application of tags has changed over time. So essentially, starting at $196 down today, we're at $174, right? So we've made some strides and some changes to help minimize the workloads that are no longer allocated by those tags. So go ahead and reset that. This could apply at any different level within your Kubernetes hierarchy. So like today, I'm aggregating by namespace, right? And I'm going to say, let's filter on my Acme Fitness namespace because that is a good example one. So it's Acme. Oops, that's not working well. Fitness. And I can see that the demo gods are not happy. So I'm going to go ahead and refresh this screen. Cool. So we're just going to go ahead and jump to another environment. And I'll go back to what I was showing here. So we're going to go ahead and go by the namespace. And I'm going to filter based on Acme Fitness. Oh, not in this one. So we're going to go ahead and choose kubectl because we know that's there at least. Right. So now I'm filtering specifically on my kubectl namespace. And if I drill into kubectl, I can now go ahead and aggregate by, let's see, I think we have managed by. No, I like the OS one. We're running Linux and everything, so that doesn't really make much sense. But let's see if we have component. Go. So now we can see in this environment, specifically the only resource I have tagged is my authentication proxy. So that's that OAuth proxy you see me walk through when I first access this environment. So now I can break down the costs based on those workloads, ultimately ending up at the pod and the container level to see a breakdown of those costs being consumed by that specific pod. I know there was a question specifically about kind of how we calculate costs and how we include like a cloud provider's bill if it's running in a cloud environment. So kubectcost takes the maximum of usage versus request when calculating the cost. So if a workload is under provisioned, we're making sure the cost reflects what the provisioned capacity is for that workload. If a workload is over provisioned, we're going to be sure that the cost is calculated based on the actual consumption of those resources. And then we're going to use a combination of the on-demand pricing of the node that resource is running on by default for an estimate, as well as how long it's run for. And then if you do hook up your cloud bill, and let's say you've got like a reserved instance or a savings plan applied to this resource, we will reconcile that. So as that data feed comes in and we see the adjusted pricing of the nodes, we'll then update our calculation to then account for that discount you get from the provider, which you'd essentially see in this adjustment column here. Right now it's $0 because I don't have any RIs or savings plans applied to that particular node. Okay. From here, we can go a number of different ways. Because we are pulling in your cloud bill, let's see if this is back. Cool. Because we are pulling in your cloud bill, that means we're also pulling in the tags associated with those resources. So basically, any of the operations we're doing in Kubernetes, we can also do with our cloud costs. I know we have an owner label. It's part of a requirement here at kubectcost. So we can see a number of different workloads are tagged with an owner equals and then the relevant party responsible for that workload. So I can do that same aggregation. I can drill into my workloads here under SPOM. I can see I've got some EKS, I've got some S3. If I drill in further, I can see the actual buckets that are tagged with that resource as well. So now I get a resource level granularity of attribution of those tags. Which can then ultimately lead to a collection. So from the kubectcost perspective, a collection is the combination of cost between Kubernetes and cloud. So going back to like that total cost of ownership discussion, a lot of Kubernetes applications are also consuming cloud native services, right? There's always going to be some semblance of like object storage or a database backing an application that may not be available to run directly in Kubernetes. So a kubectcost collection essentially allows you to define a set of rules that combine costs across environment. So as an example, we can see here that this collection is including any Kubernetes costs that are labeled with app equals Prometheus, right? So standard observability tool, time series database. But then from the cloud perspective, we're also including, let's see if we have a tag one here, which basically any service where the service is S3 and the provider ID, so that's the resource ID, is Casey Thanos Sean, so that's included in here as well. And then also including all Microsoft Monitor, right? So that's for Azure Cloud for that particular service. The one thing you will notice here is this overlap row up at the top. Think of this as deduplication, right? There is the capability of creating a rule that allows two resources to overlap. So right here, we can see we've got cloud service equals Amazon EC2. Now, obviously, that's a very wide open rule, right? So that's basically saying all costs for EC2 service in Amazon are included in this collection. Well, EKS runs on EC2, right? So there's actually a little bit of overlap between our Kubernetes clusters and that service rule. So kubectcost identifies that and essentially deducts that overlap. So we're removing $200 worth of the Kubernetes nodes that are running in EC2 from that perspective. And then ultimately ending up at savings or governance, right? So right sizing container requests. From an optimization perspective in Kubernetes, this is by far one of the most impactful things you can do. Most of the customers that we work with are running their containers in an over-provisioned capacity, right? They want to ensure that their workloads have enough capacity to operate at all times, and that unfortunately leads to a lot of idle and waste. So container right sizing can help you there. And then, of course, we can go ahead and filter by those different labels that we have applied to our workloads. So we can come in here, we do custom label. We'll go back to that app is say Acme Fitness. And now we get a curated report specific to our persona, right? Whether it be a DevOps engineer or application engineer, we can now basically get recommendations that are curated specifically for our applications and services. And then finally, ending up at governance, right? So budgets, being able to basically say, like, for this label, for this cluster, for this environment, for this combination of resources, I want to track my cost over time. And then I, of course, want to send a notification, right? So I want to say, shoot an email when I'm at 80% of my budget or 100% of my budget. And then ultimately, we'd be able to do some actions as well by integrating through like something like Caverno, where basically you could have an admission controller hit a KubeCost API to do an estimation of cost, and then if that estimated cost exceeds the run rate or the budget for that particular workload, you could actually have that admission controller prevent that work from being admitted or send off a request like a manager or team lead to approve that overrun as well. I think that's probably a good stopping point to kick it back over to you, Dee.
Awesome. Thanks. Let me share my screen again. All right. Can you all see my screen?
We can.
Perfect.
So, like lots and lots of great information about tagging today. So what are some of the key takeaways that you should like pack with you as you leave the webinar? I think number one, right, it is absolutely mission critical to standardize the way you're doing tagging. Figure out what that standard should be, communicate it to everybody, begin enforcing, adhering to those standards. It comes down to whether naming conventions, communication, alignment, positive and negative reinforcement, all of those things, but it is absolutely mission critical to standardize. You really can't do cost control in Kubernetes unless you get your tagging straightened out, right? If you're not doing good, if you're not like adopting good tagging practices, if you've not cleaned up maybe the bad, inconsistent, or missing tags inside of your environments attached to those resources, you're going to have a bad time when it comes to trying to understand like where your costs are coming from and what you can do to balance those costs, with performance. Lean on automation. Ensure that you can pass compliance checks, that you will, rise to the level of your regulatory pressures and requirements, that you're leveraging automation tools throughout your CI/CD pipeline through things like admission controllers and policy as code, using, to enforce that you've got those good tagging practices and that your hygiene is where it should be. Regularly audit everything that you're doing relative to labels and tags. This is going to catch problems before they become nightmares and headaches. And lastly, this is a family problem, right? This isn't just your problem. Work across all of your stakeholder groups and teams, whether that's DevOps, platform, FinOps, finance, to make sure that everybody understands that how, the mission critical nature of tagging, and that everybody is lending a hand and their attention to making sure that you're doing it properly and that you're doing it consistently, and it'll really pay off for you in the long run. With that, I'll turn it back over to Dee.
Awesome. Thanks, Joe. So we also wanted to share some resources for you all if you wanted to dig in a little bit further into some of the things we discussed today. So as I mentioned at the top of the call, I will send out a link to this deck as well as the recording after the session. So you'll actually be able to click on these links that I shared. So I included a couple things from KubeCost. So we have a K8s guide that's all about Kubernetes labels, as well as a blog. And then there's also some great resources from the FinOps Foundation and Kubernetes itself that really dive deep into all the best practices. So feel free to dive into those. And then we'll end with a Q&A. So we got a number of pre-submitted questions, so I was going to start with those, but also feel free to drop in any questions you have to the Q&A feature at the bottom of your Zoom there. So the first question we had was, what software can be used for tag assignment and management?
Yeah, so I mean, we touched on these throughout the webinar, right? There's a few different ways to handle it, right? So talking from like a CI/CD perspective, the tools basically help enforce that. That's your Ansible, that's your Flux, that's your Argo. The From an infra perspective, that's like your Terraform, your Pulumi, basically any tools to help you deploy that infrastructure. And then reporting, right? So your kube cost, your cloudability, even just like a standard like BI pipeline that ingests the APIs that expose those tags.
Awesome. Thank you, Sean. The next question we had was any advice on how to properly integrate tagging into CI/CD pipelines to enforce tagging policies?
I don't know about specific advice. The different CI/CD tools have different mechanisms for defining, what those labels should be or those tags should be. I'm not really sure how to answer properly integrate tagging though.
Yeah, I'd say look at the best practices, that are stated by some of the tools that we've kind of talked about today. Outside of that, there is a lot of like bring your own preferences in terms of like the mechanics of how you tag and what you actually put there as the metadata. But yeah, look to those tools and their best practices.
Awesome. The next question we had was, are tags normalized by kube cost from across different cloud providers?
I touched on this briefly. I wouldn't necessarily say normalized. We do a bit of sanitization just to remove some special characters, just to limit some display issues. We do have some concepts that allow you to kind of like normalize on your own. So kind of like talking on like how case sensitivity is important, or like the advent of like spaces or hyphens and such, or underscores in your tags. We can do like aliasing. So like if you have like cost center spelled three different ways, we can kind of combine those to like a single label. And then other tools like Cloudability also offer like a business mapping feature that allow you to combine like similar labels or tags, but maybe not that have the same name.
Awesome. Thanks, Sean. The next question we had here was, I'd like to understand the details of how and when Kubernetes costs are reconciled with Azure/AWS billing info.
Yeah, that's a great question. So the first 48 hours, at least from a kube cost perspective, are based on estimates based on public on-demand rates. That includes spot as well if you're using spot nodes. Most providers are a bit delayed in billing for the resources, anywhere from 6 hours to 48 hours, depending. So after 48 hours, I think it's roughly 36 hours, kube cost will then reconcile those resources because typically the bill's been updated at that point. So if you do have discount mechanisms like reservances, savings plans, those spot nodes, or like a negotiated commit or discount, those will typically be reconciled after roughly 36 to 48 hours.
Great. The next one was, how can kube cost be leveraged with auto scaling products?
Yeah, we work well with kind of any of the existing ones out there. So whether it be your HPA, VPA, cluster autoscaler, even things like Carpenter, we're complementary to all of those. KubeCost also offers its own cluster autoscaler. I wouldn't necessarily call it autoscaler, automatic right sizing, if you will. So like that container right sizing report that I briefly showed, we can deploy a controller that will automatically deploy those recommended sizing changes. And that's an opt-in approach. So you can basically define like what namespaces or what resources you want to adopt that automation.
It looks like we have one here live from the audience, so we'll go to this one. So Josh asked, KubeCost will provide the underutilized workload recommendations?
Yes, yeah. So in the savings view within KubeCost, there's I lost count. I think around 12 different opportunities that we surface. So anywhere from container right sizing, which again is probably the first place most people should look, to node right sizing as well. So once your containers are properly sized for your applications, then you can look to maybe change up instance types or change maybe how many instances are deployed within your environment to better minimize your idle and slack capacity in your environment.
Cool. And I think we have time for one more. Looks like we got one more that came in. How frequent metrics collecting from Kubernetes via KubeCost?
So KubeCost operates kind of like an observability tool. So we are not only consuming time series metrics via Prometheus, we are also emitting time series metrics. We scrape by default every 60 seconds. So we're fairly granular with the metrics that we are consuming. And then we build what we call our ETL. So it's standard like extract, transform, load layer that kind of builds that cost information. I believe every 10, 15 minutes. So you can get fairly granular with the window that you're looking at.